Good afternoon, my name is Kiana Waters, and I'll be presenting my team's Urban Solutions Stormwater Retrofit of Grace Ferry Shopping Center. My team members are Christine, she is our team leader, and as well as the drainage strategist. Justin, who is our website coordinator and a modeling specialist. Mohammed, who is our infiltration facilitator, and I will be in charge of maintenance and cost analysis. Our academic advisor is Mr. Bernstein, and our industry advisors are Angela Waters and Jennifer Petch. The Philadelphia Water Department has revised their water billing system from a usage-based tax as determined by a meter, and they're now charging property owners stormwater fees proportional to the impermeable area of their property. And we want to utilize 3 different types of stormwater management practices to offset these costs, which are a rain garden, porous pavement, as well as vegetated medians. Our motivation behind this project is to reduce the runoff of the highly impermeable areas, as well as minimize the cost for our client. Our approach. Philadelphia has many zoning codes that our site needs to comply with. Some they do and most they do not. As for an example, the pedestrian walkway must be connected to crosswalks. And from these 2 pictures, you can see that there are no crosswalks at our site. The second one is at least 10% of the vegetated landscape must occupy 10% of the lot surface area. And from these photos, you can see the current vegetation is really little. There's about 3 trees there right now, and a lot of dead grass, and these are the only plants there right now. Next is the ADA ramps must not have any lip between the ramp and the street. And from this photo here, on the top right, you can see that there is a lip which is against regulation, and a bottom curb cut has no lip, and that is the ideal ramp that we want to use for this site. So we wanted to transform the top curb cut into the bottom curb cut. We also want to use this type of curb cut in this photo to allow the stormwater to flow into our rain garden, and we want to place this between the Radio Shack and McDonald's at our site. The Philadelphia Water Department has 3 primary requirements that we must fulfill when designing for a redevelopment and using stormwater management practices. The first one is water quality, and the purpose of this is to reduce the pollution from runoff as well as prevent combined sewer overflows. And our main goal is to implement a dual drainage system separating the stormwater and the sewage, as well as reducing our directly connected impervious area by at least 20% within our limits of disturbance. And what that means is that we want to transform 20% of the impervious area into pervious area. To calculate the water quality volume, we will use this equation here. And the P is for precipitation, and that is the first inch of stormwater that must be captured. And we will divide that by 12 just for conversion factors and multiply that by the directly connected impervious area. The second requirement is flood control, and the purpose of this is to decrease flooding, and this is also to prevent cross-contamination between the local waterways and the sewage. Important factors to keep in mind are the location and the capacity of the watersheds. And this diagram is from the Stormwater Management Guidance Manual, and it basically says that if our limits of disturbance is greater than 15,000 square feet and we reduce our directly connected impervious area by 20%, we can be exempt from this requirement. The third requirement is the channel protection, and the purpose of this is to preserve rivers and streams from erosion due to high discharge rates. And again, this diagram is from the same manual, and it reiterates that if our limits of disturbance is greater than 15,000 square feet and we reduce our directly connected impervious area by 20%, we can also be exempt from this requirement as well. The Philadelphia Water Department broke up Philadelphia in multiple watersheds, and the reason for this is because each watershed has certain standards to comply with, and that's in order to calculate for a 100-year storm. From this map, we know that we're in the Tidal Schuylkill Watershed B, and that correlates with the second map, and that tells us we're in the Management District A. The drainage area is an area where surface runoff accumulates into one location in a local landscape. And to calculate our drainage system, we use AutoCAD, and I will get to that in a second. And we also need to use Philadelphia worksheets that's provided. in order to calculate for our directly connected impervious area. From this worksheet, we know we have to input the area for the earth disturbance, which is 241,000 square feet. And in this table, we will input our drainage areas. For the porous pavement is about 63,000 square feet. For the rain gardens, it's about 48,000 square feet. And for the vegetated median, it will be about 127 square feet. In this portion right here, in this table, this will tell us our total proposed impervious area, which is 154,000 square feet. So on the bottom table, we will again insert our drainage areas, and this is where we will calculate our total disconnected area, which is about 48,000 square feet. And the next table, again, we insert our drainage areas, and this will help us calculate our total tree adjustment, and that will amount to about 6,500 square feet. So we will take the tree adjustment number and add that to the total disconnected area from the previous table, and that will amount to about 55,000 square feet. And we will use this number, divide that by the total amount of earth disturbance area, and we need to be in between a ratio of 1 to 5, and the 1 to 5 ratio determines if our directly connected impervious area is 20% or not. And as of right now, we are at a ratio of 4.3 to 1, and that means we are at 22. We are at our directly connected impervious area is about 99,000 square feet. And with this, since this number right now is way less than what it was before we implemented our designs. So because this number is less, that means that so far it's working. So it's not hard for us to reach that requirement of 20%. This worksheet is specifically for our rain garden, and it's just to show an example of what we need to do with these worksheets. We need to complete multiple worksheets like this for each of the components that we are proposing. For the rain garden, our infiltration rate for testing will be 0.45 inches per hour, and because we're using a factor of safety of 2, our design infiltration rate needs to be 0.225 inches per hour. And right now, our water quality volume is about 32,000 cubic feet. And right now, with these values, our pounding time will be about 19 hours, and that is less than the maximum time allowed, which is 72 hours for ponding time. And that's to prevent mosquitoes from coming and turning our rain garden into like a swamp. This is our AutoCAD drawing, and this is how we obtain our drainage areas. This first drainage area is for the porous pavement. The second one is where we will put our rain garden, and the third is where we're going to put our vegetated median. The blue outline is of the earth disturbance area, is the blue line. This one has our elevations. Sorry, you can't really see. Okay. This drawing has our elevations in green. At the large elevations where our high points are and our low points are towards the center. So when the rain hits our site, it will flow. It will flow perpendicular to the contour lines towards the center for drainage area 1 and drainage area 3. However, for drainage area 2, our high points are here and here, so the runoff will flow this way, leading to our rain garden. And this is where we want to implement those curb cuts to allow the runoff to infiltrate into our rain garden. This diagram shows where exactly we want to put our rain garden, and which is right here in drainage area 2. We will place our vegetated median in drainage area 3 and a porous pavement in drainage area 1. We want to use tree canopies in our vegetated median. Tree canopies are trees that extend over impermeable area, and these are good for reducing urban temperature, as well as the leaves will absorb the stormwater, which will prevent the runoff from flowing over impervious area. These tree canopies will award us tree canopy credits from the Philadelphia Water Department, and that's if we meet the 2 criteria, is that the new trees need to be within 10 feet of the impermeable area, and any existing trees on the site needs to be within 20 feet. And if we meet these, Philadelphia Water Department awards you 100 square feet of directly connected impervious area reduction for every additional tree that you have. We will use the rational method as a starting point for our calculations to calculate for our peak runoff rate, and this is the equation we will be using to get our runoff coefficient. We will take the depth of the runoff divided by the depth of the precipitation, and that number we will make sure we're within the minimum of 0.7 to 0.95 for asphalt. We will also use the curve number method to justify the rational method, because the rational method cannot be used alone will not be accepted alone from the Philadelphia Water Department. So we use this to verify the rational method. We will calculate the surface storage using the curve number, and we obtain those curve numbers from this chart from the Philadelphia Water Department. Our curve number for our porous pavement will be 70, and for the paved parking lot will be 98. Currently, our client is charged, previously our client was charged $27,000 per month, and in about a year's time, that charge will increase over $1,000, and starting in July of 2014. To reduce these stormwater fees, we will improve about 90% of the impervious area, and for every acre of impervious area treated, the client can save $4,350 a year. So our client can save more than $31,000 a year. The most expensive portion of our project is the porous pavement. It ranges from $2 to $20, and the reason for this is if you use stone beds, what factors that you have to consider is the size of the stone bed, the materials used, and the type of stones you use, and also it could be really a simple design or a complex one. You can use something from a concrete basin or something as simple or something as a plastic interlocking units, and that is what makes the price range vary. Our estimated cost is for vegetated medians will be about $5,000, and for the rain garden will be about $13,000. So our estimated cost for both drainage area 2 and 3 will be about $19,000. We need to perform a leaching test to test the toxicity of our soil. Our site is classified as a brownfield site, which means it's a highly polluted area. We need the importance of this because if our soil is too contaminated, we need to get rid of it and excavate it. We also need to perform a porosity test to determine how runoff will infiltrate into the soil. We will test this by pouring the water over the porous asphalt as shown in this picture, and the ideal results will be for the runoff to penetrate through the porous asphalt without any blockage or clogging. We will use the compressive strength loading machine to test the compressive strength of our asphalt mixture, which needs to be at a minimum of 4,000 psi. We will use SWIM, which is a stormwater management model, to design and analyze the sewer runoff, the combined sewers, sanitary sewers, and this will help us keep track of the flow rate, the flow depth, and as well as the quality of water. And this will also will be used to model the hydrologic performance of our 3 systems. Some technical challenge and risk. One is funding. We could need more funding if we need to excavate anything from our site. What could cause that is if we fail our leaching test, as I mentioned before, and also if we implement any pipes underground. The roof leaders is a really big thing. If we implement any piping underground, the minimum slope for these pipes needs to be 0.5%. And with this minimum slope, for the pipe to reach from the furthest roof leader to underneath our rain garden, it will be too far below the rain garden, defeating its purpose. And if we implement these pipes above ground, it will give an awkward appearance to the site, and it also could freeze during winter. We need to really stress to our client that maintenance is really important to keep up. The Philadelphia Water Department only awards you your stormwater credits every 4 years, and that's to motivate the client to continue to maintain their site, as well as make sure they stay on top of utilizing their stormwater management structures. These are some of the maintenance that our client would need to follow, and it's very important to follow in order to keep their stormwater fees at minimum. This is our project schedule so far. We had many site visits, and we had numerous meetings amongst ourselves and our advisors, and we started our AutoCAD drawings, and we're still in the process of learning SWIM. In summary, we've done some research on stormwater management, designed our 3 components, started estimated costs, CAD drawings, site investigation, as well as preliminary stormwater calculations. In senior design 2, we want to finalize those calculations, perform a porosity test, ensure well quality, produce a prototype, as well as a swim model. And these are our references. Thanks.
Questions?
The water that the runoff, are you going to test for pollution or are you just going to let it go into your?
What we want to do is we want to not let we want the runoff to flow into that has contaminants to flow into the ground, and then the water that doesn't have the contaminants, we want that to continue into the sewer, because it won't when it gets to the water treatment plant, the stormwater doesn't need to be treated since it won't have contaminants in it. So if that flows on, that's okay, but just the runoff that will have the contaminants, we want that to infiltrate down into the ground.
How do you separate that?
We will use a dual drainage system separating the stormwater. So when we use a design for the pipes, we will separate it, but we don't actually have the design for the pipage as of right now. But when we design it, we will design it so it will be separated.
I don't get it. How are you going to separate the polluted water from the non-polluted water?
I'm sorry.
You said polluted water will be separated to go in the sewer, go to the treatment plant.
Well, we
How will you separate that? I mean, how will the pipe separate that? Which one goes where?
You mean from the pipes that we use if we could use the roof leader? Well, with the roof leader, the issue with that is that because of the current infrastructure that's there, the pipe from the roof leaders, from the runner from the roof goes to the roof leaders and into the pipe. The current drainage goes to the sewer, and that's an issue. We don't want that water to go into the sewer because it still contains all the contaminants. So our goal is to, if we still use the roof leaders, is to have the pipe connect to the rain garden, so those pollutants will infiltrate into the rain garden first, and that will retain the contaminants from the runoff water. But because what we're having, there's some challenges with the piping going to our rain garden, because at the current slope that is at and the minimum slope, if we implement any new pipes, it will be far too far down to below our rain garden. So we're having issues with getting around that issue, but we're not ruling it all out as of yet. We're still going to research a way to make this feasible, but right now it's not feasible for us to use the pipe, so we're still considering a different option.
Okay.
Early on, you talked about channel protection,
Uh-huh.
and I think flood protection?
Yes,
Channel and flood
control,
protection?
yes.
And how, given certain criteria, you would get an exemption from the flood. All right, so here you've got an exemption from the flood control requirement, is it?
Mm-hmm. As well as the channel protection.
Okay, so these exemptions are just, okay, all right. You talked about Management District A. What is Management District A? What does that mean?
The Management District A is corresponding to, sorry, I just wanted to find is corresponding to the Watershed B. Because we're located in the Schuylkill Watershed B, that means that will correspond, is based off the location of our site. And our location of our site is at 29th and Grace Ferry, and that falls into the Management District A. And what that means is that there's certain criteria or standards you must follow when you calculate for your 100-year storm. So the reason why the watershed, we follow in the watershed is important is because there's certain for standards we need to follow to calculate for that. And it's different for each watershed that you're in, determined from the Philadelphia Water Department.
Okay, and so you're in Management District A, so what does that mean for you?
That means that we have to follow certain criteria to calculate this 100-year storm. So we couldn't, say if there...
Well, can you tell me what those criteria are?
At this time, no.
Okay. You talked about in the tables, you showed some calculations in that, one of them that had a 240,000 square foot of land disturbance.
Okay, that is, all right. Here.
So are you actually disturbing 240,000 square feet of area?
No, no. What that means is this, the limits of earth disturbance is what's already the limits of activities where disturbance can happen on this land. And from our AutoCAD.
So that's the entire property.
Yes, that's just covering this entire parking lot. It doesn't include any of the buildings. Well, it includes the McDonald's, but not any of the other buildings.
All right, but that's not the actual land you're disturbing. You're just, that's
Yeah, that's
the
just the
drainage
total.
area for the land that you're actually disturbing.
Yeah.
And I guess I want to go back to the question on water quality that Goodwin Yang raised. Because you mentioned about water quality modeling in SWIM. Are you planning on modeling water quality in SWIM? Is that part of your plan?
Yes, we want to see when we actually come up with our final design and we understand how to put that into SWIM. We want to see if our design, if the infiltration rates will be sufficient. Because if it's too fast, then the contaminants will not be retained in any of our proposed stormwater practices. So then we would need to either make it slower or just manipulate it a little. So we want to use SWIM to see how well our designs will work right now, and if they don't work, we will go back and try to recalculate our numbers.
Because SWIM has specific components to model nutrient uptake or phosphorus removal or sediment removal, et cetera. As well as separate components to model the hydrology and the hydraulics. Right? So just knowing that whatever your infiltration rate is doesn't tell you anything about water quality.
Okay.
Okay, so to do water quality, you've got to get a whole different set of parameters.
Right.
It's an undertaking. Don't take it lightly. Okay. Are there other questions?
You may have addressed this, but you mentioned once that you'll be using, I can't remember the name of it, but some sort of formula to calculate it, but then you said that Philadelphia doesn't accept this. So
Oh,
you're
right.
using something else
You're talking about the rational method as well as, okay, we want to use the rational method just as a starting point for our calculations to determine our peak runoff rate. And the Philadelphia Water Department doesn't allow you to use that by itself. So we want to compare that with the curve number method, and we using the rational method just to see if we're in about the same ballpark of our calculated runoff volume. So that's why we're keeping both of them. We're using the rational method just to see how well if we're on track, basically, with our calculations. Because we're doing all of our calculations by hand and also using the worksheets, because that also gives you a Q value. So we want to just make sure that we're in the same ballpark, which is why we're keeping both methods. But yeah, this is the one that's accepted and the other one isn't by itself.
So then I guess my question is, if this is the formula that Philadelphia cares about, why isn't this your primary formula?
Well, we're just using the rational method as a starting point because it has less variables. So it's a really simple way to calculate this. So when we figure out the rest of our variables and we put them into this equation, because like for this one you need to know the surface storage, you need to have curve numbers, and again the precipitation, that's the only two that's the same in both methods. So we just wanted just to see if we're in the right range of our runoff values.
Okay.
Okay. Thank you very much.